Good evening, guys. How are you all? I hope you all are fine. Today we are going to see the Arduino programming on a smart irrigation project. Smart irrigation project is a kind of project where we are controlling the movement of water to the plants or to the any other objects with the help of internet. So here the things that we are using is the moisture strip, we have connector, then we have relays, some sort of switch or button you can say, then we have motor, then this is called NodeMCU, and NodeMCU has a Wi-Fi facility. So this provides a Wi-Fi facility. So this is the circuit connection. So if we see the circuit connection over here, all these wires are connected to the ground, and one wire comes from the relay, one wire comes from the connector, that from the connector to the sensor, moisture sensor. And one point, let me tell you, the VCC is connected to the 5 volts, that is V in. And similarly with respect to relay, and and the ground pin is connected to the ground pin onto the node MCU. And from here one pin of the connector, or which is connected to the moisture sensor, is connected to the A0 pin, and from the relay pin it is connected to the D0. So this is how the circuit connection in brief. I know it is a bit messy, but let us try to understand. So from COM section we are connecting one point, connecting to the water pump. And from sorry, not from COM, from NC. And from port COM, it is connected to the this is connected to the voltage V in. It is connected, we have given the common base to the V in. So here we have water pump, and this is a small water pump which is connected to the relay button. Now let us look at the coding part. Now in coding part, we are including files such as ESP8266 Wi-Fi.h, Adafruit MQTT.h, and Adafruit MQTT client.h, and ticker.h. Ticker.h is a kind of header file which is used to interrupt the session. So which is used to interrupt the session, and this kind of header file is required. And here we are giving a ticker class, and this is object. So we are declaring int flag equal to 0 and param equal to 0, and later we are giving, this is the what we call Wi-Fi uh, username and Wi-Fi what we call password, so to get access to the hotspot. And we have server name io.adafruit.com. You can use blinking also app which is there on mobile, and but we are using standardly, we are using io.adafruit.com. AIO server port is 1883. Username is Prasad Speaks. So how did we get this username Prasad Speaks? So this is how we have created the username Prasad Speaks, and here we get the password, that is active key, right? So here we are copying these things over here. Now we are giving the relay. So relay, as we have seen, the relay is connected to the D0 pin on NodeMCU. You can see here. See, this is D0 pin. Okay. Now we are creating one more class, Wi-Fi client. Okay. After that, we are saying we are setting up the MQTT client class by passing in the Wi-Fi client and MQTT server and logging details. So after that, we are connecting the buttons and moisture gauge. So let me show you. So this is the button, this is the button for a pump, and this is a moisture. It shows how much moisture is there in a particular soil. So this so it will have the, for example, if I want to see the pot value, pot name, so I can see here pot name, so moisture gauge. Okay. Similarly, I can see the feed name of this button, BTN pump. Okay, you should name accordingly. Please do not name the blocks confusingly with a confusing name. Have some meaningful names for a particular block. So now let us go to the next part. So here we have linked the pots, since feeds, okay, moisture gauge and btn pump. Now we have here one function mqtt connect. So this function will connect to the wi-fi, okay, int rt ret. So if it is, it's uh, if it is connected, then it will return, then connecting to mqtt. So this specifically, this is with respect to the connection of wi-fi. So let us not go deep into this. Let us come back. Now Adafruit MQTT subscribe asterisk subscription, while subscription equal to MQTT subscription 5000. If subscription equal to ampersand of on off button. So there we have declared one block on the Adafruit. For this we are coding for this part. Now if it is equal to ampersand on off button, then what we get, serial dot print, we are saying got. What we will print here, status. We have to see the status, okay. Char on off button last read. So if it is off, it will get OFF. If it is on, you'll get ON. So if status dot equals is equal to off, what? If it is equals to off, then we are saying flag 1 and we are printing flag 1. Okay. Now if status dot equals is on, then we are printing flag. We are storing a value in a flag variable equal to 0, and we are just printing the value just for the sake of confirmation. And next we are declaring one sensor value, and we are reading from analog read. Analog read a naught will come from the where it is, analog read a naught is coming from the moisture sensor. So it is connected over here. We are reading the value and then we are converting into the percentage. So the value, the sensor value divided by the maximum value 1023 into 100. So after that we are printing the moisture percentage, and then we are giving a delay of the of 5000 microsecond, nothing but it is a 5 seconds. Moisture value dot publish, then we are publishing the value on the serial monitor. So this code, particularly this code, is responsible to print the value. See, since the moisture sensor is present in water, the moisture value is around 34. Now okay, so this is the code to, responsible for printing the moisture value onto the Adafruit block. Okay, now what we are doing here is, if flag equal to 1 or param equal to 1, digital read relay comma high, it is like switch button. This switch button is high. So when it is high, it means what? It will turn off, right? But actually it should turn on, but there is some manufacturing defect, so that's why it is turning off. So flag equal to 0 or param equal to 0, the button will be turned on. So when I say turn on, it means what? The motor will be turned on over here. Okay, if it is turned off, the motor will turn off. So let us go to the next part. Now we have here one more method called void pump on. So this method will be called, so this void pump on is a method which is included into the ticker 1 comma pump on. What is the use of this method? This is used to even to control the motor from the Adafruit interface as well as manually. So this method will help us to control the motor manually as well as online. So let us see that method. Okay, so here also same, we are sensing the value from a naught pin, and then we are storing, we are converting into the percentage, then we are printing the value. And now here what we are doing, if moisture level is greater than 10, param equal to 1. So when param, and then we are printing, normally we are printing, else the param equal to Okay, if param equal to 0, serial dot print param, so we are just printing the value. So param is used to generate a flag number, and now we use this param value as well as the flag value, and if both are equal, if any one of the condition gets true, if flag equal to 1 or param equal to 1, it will turn off. But generally here it should be low, but there is since a manufacturing defect in some devices, that's why we are using this the high keyword. So flag equal to 0 or param equal to 0, it should be low. So we are normally printing this statement. So this is how we have uh, coded the source code in smart irrigation projects. Now let us see the dashboard. Now in dashboard we have created one gauge meter. So here I have given moisture as the label and 36 is the value. Why 36 is the value? Because it is already present in a water. Actually I should keep a soil, but since we there is no availability of soil, we are using a container with the help of water. You can see there is a water. Let me tell you, this is a water. Okay, so now I can use, okay, these blocks. By default it should be on only, it cannot be turned off. Okay, now if I turn off, there is no action or generated on the motor. Okay, or if I turn off, there is no action, but by default it should be turned on. But the moment I remove, now the moisture level is 36, you can see over here. uh, Now the moisture level is 36, you can see over here. The moment I remove the sensor, what happens is, see, the moment I remove the moisture sensor, the gauge meter is 0. Similarly, the motor has started. But the moment I put it inside the water, what happens? The what? The motor stops. You can see over here. The motor stops, and here the moisture level will be reflected onto the gauge meter. See, it is 44 value. This is the highest, I guess so. This time we got very highest level. So this is a 44 level. Now in case of when we are placed at a distant places or remote places, at that time how can we turn on or turn off? Suppose the if it is kept outside, means what, if the soil doesn't have the sufficient water, then we can turn, then you can check the moisture level, and then we can turn off and turn on the machine. See, it is now turned off, right? Now we can turn off also. You can see, even if the moisture is 0, we can turn off. You can see we have given the delay of around 5000 microseconds. So it will take more than it should take 5 seconds, but it is taking more than 5 seconds, around 10 seconds. So you can see the motor is off. Now if I want to turn on, okay, suppose here I'm clicking, I'm turning on here. Okay, so the moment I turn on here, you can see after 5 to 6 seconds the motion. This is how it works. So if I turn off, you can see it. Now it is already turned on, and now I'm putting the moisture sensor. What will happen? The moisture value will increase, motor will turn off, and there we are getting the moisture value as 42 on the block. Now we have done this delay purposefully because sometimes it is very difficult to get the values. So in order to remove the messiness while programming, we have given a delay. So this is all about the smart irrigation project. I hope you all have understood this session, and please like this video and share this video with your friends and subscribe to the channel. Thank you and good day.